Today we're going to have another look at the RC2014 Z80 Retro system we built to show off the USB storage card. Our first addition is a little power card from Small Computer Central, SC148. This low-profile power supply module is designed for the RC2014 bus and provides both a handy on-off switch and a voltage regulator to power the bus with a 5V 1A supply. You can, if needed, also supply 5V to power any external devices in your system. If you're putting your computer in a case, there is a port for the connection of an external reset switch, making this a very useful addition to an RC2014 system. We'll be using the barrel-style jack plug today from a little power bank. As you can see, the USB storage card sits towards the back of the computer, with a 32GB low-profile USB drive already inserted. This was the USB drive we prepared in the last video. We are also going to add a graphics card for the RC2014, which is a TMS emulator and 80-column color terminal, having HDMI output and USB keyboard input from the MIDI-in company. This will allow our Z80 system to be fully standalone, with its own keyboard and monitor. Now to have a look at the software we installed in the last video. Unfortunately, my HDMI capture facilities cannot capture what comes out of this video card, so we'll have to point a camera directly at the screen. So here we are looking at the initial boot up. If we enter 5.1 to boot from the USB drive, we can launch ZS-DOS. And there are all the volumes now showing. If we execute a dir command to see what's showing on the A drive, and there are all our files. There is quite a lot to look through on this, but initially I'm most interested in the various versions of the BASIC language. So I did come across a version of BASIC that I was not familiar with, dating back to 1978, and that is TDL BASIC from Zapple. This was a 12K BASIC, unusual for its time as most BASICs were 8K in size. And this was version 3 of the software, with some very useful features, particularly the handling of high-precision numeric values. If we launch TDL BASIC to see how it looks, and there we are, now running. As I'm unfamiliar with this dialect of BASIC, reading the manual is always a good idea. And perhaps not surprising for its time, it refers to loading and saving to paper tape. Not having a paper tape reader or writer to hand, I delved into the manual some more, to discover that the CP/M version of this language did support drives too. So to see how this version of BASIC compares with another, I'm going to create a program to calculate the value of pi in TDL and Microsoft BASIC. But we'll switch back to TeraTerm so you can see better what's happening on screen. So first we will run TDL BASIC and open up a program that I created earlier. Unlike some versions of BASIC, the loading and saving process is a little different in this dialect. First, we have to open a channel, and it only supports one at a time, so no opening multiple files. We open it for input and name the file. Next, we need to use the load command, which in previous versions was geared for paper tape. This takes a single character ID and a comment. Then we close the channel down, so our application should now be loaded. So we can now run the application and enter its single parameter. This output will give us an approximation of pi with 11 significant digits, which is quite close to the actual value. And now we will launch Microsoft BASIC. And there we are inside Microsoft BASIC. And now we'll enter in our application, and we will run it to see the comparison between the two dialects of BASIC. And we put in the same single parameter, and there it's calculated the value of pi. As we can see in the Microsoft version, although we have a large number of significant digits, where it matches with the version of pi, it only goes to about 7 significant digits. After that, it does diverge. So if we compare the two values, we can see the actual value of pi to quite a number of significant digits. Although Microsoft BASIC does actually store it to a greater number of digits, it's only correct up until the 7th digit. After that, it does diverge. However, TDL, enabling a higher precision, does go much further. So I can now see why this particular version of BASIC was used where high precision values were actually required. And although this particular dialect of BASIC was unfamiliar to me, I can see now why it would be quite popular. It has a wide range of commands and a higher precision of variable values, especially useful where you required your numbers to be high precision. However, that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.